And it describes the 14 principles of the Toyota Way. And the 8th principle is to use only reliable, thoroughly tested technology that serves your people and your processes. It's not the other way around. There's an if statement there. We will use the technology if it serves our people and our processes. If. We don't just put it in because it's the coolest thing. It's the latest thing. Everyone's doing it. It has to serve the process and the people in order to be successful. Dr. Denning preached this years ago. This is a principle. So what? You might say, what's so what? It's a principle. Principles don't change. Principles don't change with time. If it's a principle 100 years ago, it will still be a principle 200 years from tomorrow. This will always be there as a principle. It's there to serve us. What we have done too often is get crazy about the latest thing and just do it. Like the Hamtramck plant and robotics. And they inserted their robotics needlessly. Collaboration is required because we also have that process focus. We understand about processes. A lot of organizations complained about their implementation with SAP. And one of the complaints was that it was department focused. It was functional focused. It was not process focused. This goes for other software programs, ERP systems as well. Okay? What's the point? The point is that technology itself, by itself, may not have a focus on the process like we all know is important. We know about how to build and sustain a culture of continuous improvement. We know how to do that, and that's still going to be necessary 100 years from today. We understand the tools of Kaizen and understand the concepts and principles behind them and how to use them in the electronic world, in the cyber physical world. We have to change our thinking. It's like something like 5S as an example. Everyone associates, pretty much everyone associates 5S with the physical world. A maintenance department, a process area. Does 5S have a home in the cyber physical world? Does it have a home in the networking world? Absolutely. Big time. Think about the messes that you all have and I have on my laptop, in your networks, in your folders. That's our working space, and yet it's a disaster in many organizations. How did these programs work together? How did they function together? How did they communicate? Is that clearly understood? Because if it was, or if it was not, then we're not applying the second S and 5S, which is set in order. Why does it take so long to run our programs? To find our files, to find our folders? Because it's not set in order. So all of these tools have a place. And we understand those tools. We just need to understand how to apply them in this new cyber-physical world. It's all applicable, though. We also understand how to manage the value stream, the importance of the value stream. The importance of the value stream over departments, over metrics. So, I thought what I'd do is show you a few examples. Just a few examples, and there's many more than this. But just some examples on some of the common tools that we have in the Lean world, in the Kaizen world, and kind of say, well, how does this relate to Industry 4.0? So some examples that I'll just briefly cover: TPM, and overall equipment effectiveness, the 3 golden rules of Kaizen leader, Poka-yoke, standard work development and improvement of standard work, SBC, Kamishi buying, and 5S. So go through a few examples. Total productive management, and of course the key metric, overall equipment effectiveness. We talk in TPM about the 16 losses. What are those 16 losses? I don't think I've ever known anyone to memorize them all. And I'm not actually asking you to recite them. But which of those 16 efficiency losses might be positively affected by a cyber-physical system? How can it help us in the Lean Kaizen world? How can it help us if we introduce some cyber-physical systems? Well, here's your 16 kinds of losses. Many of you are probably familiar with these. You got your availability losses, your productivity losses, and your production losses. If we looked at the first one under availability loss, we have machine failure losses. Okay, so if we introduced Industry 4.0 into machine failure losses, we would understand the types of failures that we have, the frequency. We would be able to predict when those failures could occur in the future. When we have failures, we would be able to communicate, the machine would be able to communicate with other machines to increase or decrease production. We would have the data as to why those failure losses occur, and with that data we can make wiser, more supporting decisions. Machine failure losses also could result in reduced output. If we have reduced output, then it might affect logistics and how quickly we bring materials or parts to that line by communication between the two systems. So that's an example. Setup and adjustments. With setup and adjustments, we can have real-time data on how long it does take to do a setup, to do an adjustment, to do a changeover. And as we have that data, we can react to understand, well, what's going on? So Industry 4.0 would allow us to say, okay, we are behind times, we are behind the standard. What do we do about that? Who do we communicate that with? What alerts do we send to certain people so that we can react to it real time, not later? So we continue to go through this list of the 16 of the overall 16 kinds of losses, but I think you understand that in TPM alone and reduction of these losses, that Industry 4.0 can be very beneficial to our needs, to what we're trying to do. When we try to eliminate our losses, we typically have our 5 targets. The 5 targets to zero losses include maintaining basic manufacturing conditions, maintaining operating conditions, eliminate breakdowns, identify and eliminate failure modes, and improve quality performance. Now, how do we do this? Where does Industry 4.0 fit in? Where does a Kaizen culture fit in? Well, I would say they both fit in at different parts. Maintaining basic manufacturing conditions is a report system, a loop-back system. If we're not maintaining operating conditions, including facility conditions, that information and data is brought back to the correct machine. It's brought back to the correct equipment, whether it's facility related or production related, and it adjusts accordingly so that we can maintain those. Same thing with our operating conditions. So Industry 4.0 can help us definitely with those first 2 steps. Now, eliminating breakdowns, that's kind of a combination. Industry 4.0 will provide the data that we need and understand the cause and effect relationship from one machine to another machine and see where those causes or potential causes are. But in order to decipher root causes, we need people. We need the Kaizen culture. We need people focused on problem solving. Identifying and eliminating failure modes. That's a combination of Industry 4.0 and developing that Kaizen culture together, hand in hand. And of course, improving our quality performance. We need a Kaizen culture to do that. So the point is to show you that Industry 4.0 can aid us in a tool such as TPM and increase our overall equipment effectiveness by integrating the two. By not fighting the system, but by teaching technological experts about the 16 losses, understanding those and saying, this is the information that we need, this is the data that we need, this is how we need one machine to react to another machine. Now, what about the 3 golden rules of a Kaizen leader? At Kaizen Institute, we talk about the 3 golden rules of a Kaizen leader. So I ask you, if I show you the 3 rules, which of the following golden rules of being a Kaizen leader might be positively affected by a cyber-physical system, and how? Well, our golden rule number 3, we're going in reverse order, so 3, 2, 1, is to implement required improvements and identify more potential improvements. How do we do this? We, of course, use practical problem solving. We encourage team members to do the same. We put a containment action in place. We look for root cause analysis and try to determine the root causes. And we ensure our improvement is somehow linked to a KPI that the team has control over. So, the question is, how can Industry 4.0 help us to improve this? Can it? Does it have an effect on this golden rule? And I would say yes, it does. It does. First of all, with Industry 4.0, we'll have the data. We can determine what data that we need. But if there's a problem, we can understand what are the potential causes, either previous processes, previous materials that are used as inputs, previous tools that are used as inputs, because this data would be available, and we could see that relationship between cause and effect. If we're able to gain that data and information by looking at and analyzing the data, then we can do a much better job at improving the overall process and the KPIs. Golden rule number 2, monitor and communicate team performance. Today we talk about using the visual team board. Team board should be at the location of value, where value is added. Ideally, we like hour-by-hour management and hour-by-hour feedback. In the Industry 4.0 world, we can improve upon that. Maybe we can get half hour by half hour, 10 minute by 10 minute, 5 minute by 5 minute, 1 minute by 1 minute, part by part data. And be able to react to that real time. The goal is to get to the point of real time. We've been talking about it for decades. We haven't done a good job with it. This is an opportunity where Industry 4.0 can give us this data. As far as visual team boards, I don't care if it's electronic or if it's manual. It still applies. It's still necessary for us to see the score. Just like at that football game. American football or regular football. We need to see that score all the time. Can you imagine going to a football game and not seeing the score and how much time is left? That will still always exist as long as we have people. It can just now be improved. Golden rule number 1, respond to team member call within cycle. I'm trying to remember the term Sebastian used. Is Sebastian here? What was it? Some kind of boost? Alert boost? No. Anyway, you're going to look at your notes. Reaction boost, thank you. Reaction boost. This is the same thing here. This is that reaction boost. So in one of the organizations that I've worked with, they did that. They had a nice little system that did work. Anytime the machine went down, there was an alert sent to the team leader's phone. And that team leader had to go over to the machine and press a button to signify that they were there and working on the problem. Now, they could actually press the button and walk away if they wished to, but there's some level of accountability because all of the team members see that person in the area, and they're going to want to have him work on the problem. If that person did not respond, that leader did not respond within 2 minutes, then automatically an alert would go to that person's boss. It was an accountability system that went up the ladder. Okay? That's all through Industry 4.0 technology. It's the communication between two devices that would not normally communicate to each other. Forcing a reaction, forcing something to happen. This would allow this to happen. This would can improve the ability of a team member to call, to be there, to resolve the problem, to help resolve the problem within a certain cycle time. So that's one other element. How about another element? Something like Pokeyoke. or mistake proofing. Well, let's break down mistake proofing. What are the different types of mistake proofing? Well, you have the best form of mistake proofing. That's through contact. Contact involves the physical contact between two or more things. So as an example, an electrical outlet, it uses physical contact or a physical shape to prevent wrong voltages being plugged in. We know about that. It's the best form. Do we have these types of examples? Do we have these types of examples in the cyber-physical world? Well, yes, we do. They're just different. It's a different type of contact. I mean, if you're ordering something on Amazon or wherever it might be, and you have to input information, and you're supposed to input your email address, and then input it a second time, and if you don't type it in correctly the second time, it's not going to let you go further. It's a type of mistake proofing. It's a type of contact mistake proofing. So, in the cyber-physical world, it still applies. Our abilities, our capabilities to make sure that mistake proofing occurs in these examples are still present. The second best types of mistake proofing include performance step. That involves monitoring steps and process and trigger an outcome if the step is not performed correctly. This is today's world. This is what we do today. We've been doing this for years. What's the difference? The difference is that now, in an Industry 4.0 world, we're going to involve monitoring steps in a process and triggering an outcome in another process, on another machine, in another building, at our supplier's location. It's not that machine. We're taking it elsewhere. It's the same idea. We're just applying it in bigger scope. And the same thing with the second part, fixed value. It involves setting specific values that trigger an outcome and having that process count up to that trigger. Now we just don't do it on that machine, but we do it on another machine. What happens on one machine can affect another machine, or it can affect logistics in another area. And so all we're doing is using Poka-Yoka concepts at a higher level, at a bigger scope, at a bigger picture. The third best type of mistake proofing is just making it easier to do it right. These are your visual things. Colors and color coding, symbols, shapes, operator omniscient audio detection, checklists, forms, procedures, simplified workflows. Okay, we will have now more complex workflows that will be harder to understand. All of the programs and the interactions between the programs, the PLCs, the machines, will be harder for the common person to understand. It's our responsibility to make sure it's easier to understand. However that's done, by improved workflows, by hyperlinks, by whatever methodology that we see, it's our responsibility. Again, in the previous presentation, Sebastian shows you some registries. And you saw in some examples of the layout and what it looked like. That layout of the registries is all can be 5S. It has a lot of visual controls. It should be easy to read, easy to see. These things still apply. It's just in the electronic world versus our physical world. What about standard work development and improvement? Can that be positively identified or positively affected by the cyber-physical systems? Well, we know that with regard to standards, we push up this wheel of improvement. We do Kaizen events. We move it up the hill. And then immediately after that, we try to develop that new standard and shove it under there so it doesn't fall back. That's our goal. And we do that continuously. This is just an example of standard word combination sheet. Many of you may have something similar to this. Just to kind of explain it, because it's kind of hard to see. The thick horizontal lines represent what the operator is doing, a task that they're doing. The little squiggly lines in between represents transportation, or his or her walking between those steps. The dashed lines represents the machine time. So that's kind of it in a nutshell. That's a standard word combination sheet. So how does Industry 4.0, how can it positively affect us? Well, one of the things you can do is monitor this. Let's see real time how we do compared to this standard. This is our standard. This is the way it should be. How often do we check ourselves against the standard? We can monitor machine times. That's not a problem. We can also monitor human being times. We can integrate those as two different data sets and bring them together and compare how our actual standard work compares to our expected standard work. And if there are issues or problems, we can make an alert and identify this as an issue and something that we as human beings in a Kaizen culture can fix. So standard work development is something, and improvement and adherence, is something that we can greatly improve through the introduction of Industry 4.0. What about SBC? Okay, SBC is not a lean thing. It's not a Kaizen thing. It's a quality thing, you might say, but it's got the same purpose. To improve, to control. Here's a common SBC chart. As I said earlier today, a lot of organizations, they try to do SBC, but they don't really. They look at the data much too long after the issues occurred. In the ideal world, SBC data, we see it now, we plot it now, we do something about it now. Anytime we have an out of control point, which is a point above or below the red line, or we have a trend of 6 or 7 data points, or we have a run where we're above a line for 6 or 7 data points, depending on how you define it. Any of those types of occurrences, in the ideal world, the way SBC is supposed to work is that we react to it now, and we make an adjustment now. But we don't do that. But in Industry 4.0, maybe we automate that. Maybe when there's an out of control condition, we change the machine parameters. Maybe, because components can talk to each other, if you have a component on the high end of the spec, not out of control, but on the high end, we can ensure that the components speak to each other and match up with a component on the low end of the scale. Maybe that's a possibility. The point is that we're using this data, this data that we have, and we're using it to control other machines or productions or other parts that are coming in. What about Kamishibai? I don't know if everyone has a Kamishibai system, so let me just do a brief explanation, just very brief, and then we'll ask the question, how might Kamishibai positively affect the cyber-physical system? Kamishibai is love. I've always loved it. I love to get to a point with a company where we can introduce it because it's so necessary. It's just a very simple visual auditing system. So how does it differ from another audit, normal audit? Well, number one, as I said, it's very visual. It's easy to see. And number two, like in the lean concept, it's better to do things in single piece flow than in a batch. So in other words, I bet many of you guys out here are with companies that are ISO 9001 certified. And you have to do audits. And it's something you dislike and you disdain. And it's not very effective. And maybe you audit that process once a year. Does that really work? It doesn't. It never works. That's doing an audit in a batch. Doing an audit in a batch doesn't work. But if we believe in audits, we should be doing audits every single day in little bits and pieces, right? It's like if you have kids, if you want to make sure that their room stays clean, you go in there every day and you ask them about something that's out of place all the time. Instead of doing it in a batch when the room becomes a disaster. So the Kamishibai audit system says, you know what, do many little audits on important little topics. Once a day, frequently. Maybe no more than 15 minutes, but do them. So you might have a card system. Each process has an audit card, detailing maybe the check that's required. So in the example on the right, you see standard work. Standard work is a thing that someone will audit every single day. And the detail underneath that might say, audit job instruction XYZ or standard work ABC, wherever they are in the process. And you pull out that standard work, and you go and you audit it for a brief period of time. What are you doing? You're showing how important to the people in the organization these standards are. You know, one question I oftentimes ask people, whatever you call it, I don't care what you call it, if you call it standard work, or job breakdown sheets, or job instructions, or work instructions, or whatever you call it, it's the thing that operators or people are supposed to do on the front line. Okay? Who is the customer, the main customer of those documents? Who is it? Operator? Yes, and that's what everyone says, but I disagree. I forced you into that answer. Everyone says it's the operator, but the products? Okay, you could say the products, but I have another answer. But I can understand the products. So we all say it's the operators. The operators don't care about those things. They'll never look at them again. I don't know how many companies I've gone into where they hang up the work instructions. No one ever reads them. No one ever reads them. The true customer of those documents is the team leader, the supervisors. They're the ones that have to use them. How do they use them? They pull those things out in accordance with the Kamishibai audit or leader standard work, and they audit against those because those are their documents. They own them. So a Kamishibai system says, it's kind of like a layered process audit for anyone who's in the automotive industry. It has a lot of overlap with a layered process audit, except it's visual and it's every day in short bursts of time. And I believe it's much more effective. So the Kamishibai system is there to make sure that the team leaders, the group leaders, the supervisors, whomever it is, all the way up the line, are making sure that the standards are being followed through a brief little audit every single day. Now, what are some of the examples of the things that we can audit? Standard work, our process parameters, meaning pressures, flow, temperatures, pH, viscosity, whatever it might be. PPE might be another topic. Visual aids, total productive maintenance. These are the topics. These are the things that we can perhaps audit on an every single day basis. So these little cards that we have basically have the same exact wording on the front side and the back side. On the front side, we color it green. On the back side, we color it red. So then when we do our little mini audit, because it is so visual, we do the audit, we complete it. If everything's fine, we put the card in a card holder for that day or that shift. So everyone knows an audit was done. Everyone knows an audit was done. And they know the result. Green is good, no problems. Red, we had a difference between expectations and real performance. If we have a red card, then we need to do something about that. And with that red card, we initiate a concern, maybe use a 3C form, concern, cause, and countermeasure. Now, how does this affect Industry 4.0? Is there a relationship between the two? Yes, there could be. Okay, nothing will ever replace going to the Gemba. However, if we're doing checks on process parameters or TPM, some of this data we can go ahead and check. We'll have this data. We have it available, especially with regard to process parameters. Let's check the process parameters of the parts of the machine, of whatever it might be. And we have that data, and we can do this automatically at many different machines throughout the entire process, and they're looking at the relationship between the two so that we can understand where there might be deficiencies when we compare our standards to our actual results. Okay, and what about 5S? Well, 5S is, as I said earlier, very interesting in that a lot of us tend to think of 5S as strictly a physical thing, a physical phenomenon. And it is. It's just that our physical world now in the cyber physical system changes. And we have, as I said earlier, a great deal of messiness within our folders, our landscape, our interaction of processes, our programs, the relationships between our programs, our registries, and it is an unhealthy environment for process flow. And we don't do much about it or to control it. 5S has a great application. Any of the forms that we have, any of the documents, any of the workflows that we use. I mean, I've worked with insurance companies and financial companies, and they'll print out every screenshot of everything that they use of the programs. And they go through a 5S process. And they eliminate all the stuff that they don't use. They get rid of it. Then they set it in order because how they enter information into the fields is all over the place. Now they enter information into a workflow pattern. So it's very applicable in this world. Chevron did a study one time and documented and recorded and documented that the typical office worker spends 10% of their time looking for files. Do you buy that? Does that make sense? That's over 1 hour a day looking for stuff. We don't see this. You know, we talk about the skill of seeing waste, but sometimes we don't see our own waste when we look for things. And how much those seconds add up to perhaps hours. When we introduce Industry 4.0, when you do that, you will have many different systems. You will have different programs, databases, talking to each other. How that's laid out is an application for 5S. It needs to be laid out and understood by the common person so that we can help to fix it. We need to bring the technology to a level that more people can understand. That's our responsibility to see how that relates. And that's part of the relationship between 5S and Industry 4.0. So brief summary, very quick. Industry 4.0 is here to stay due to the immense potential in gaining competitive advantages. That's what we want. In the Kaizen culture, we want those competitive advantages. So Industry 4.0 is there to help us. We need to embrace, our operational experts need to embrace those cyber-physical systems into our lean efforts. But the lean efforts in Hoshin Kanri should mark the direction, should lay out the direction. And how we do that as part of the third quadrant or the fourth quadrant of an X matrix in Hoshin Kanri. As part of that, how we do that is partially related to Industry 4.0. Remember, this is a cyber physical system. It's not just cyber, and it's not just software. It's also physical. Those elements haven't long left. We still need to emphasize the importance of people systems, visual management, and process and system focus continuously. Because as I said earlier, our technological experts may not get this stuff. They may not know this, and we are the experts in these areas. The OEs and the TEs, they need to collaborate, especially during value stream mapping efforts. And the great benefits will truly be realized, even further, when we incorporate into other cyber-physical systems across the entire scope of the value stream, with our supplier base, with our supply chain, with our customers, across our geographies. There's great potential so that when there is an issue in one plant, there's a machine in another plant that understands that issue and is changing what it's doing. It's modifying its approach, it's modifying its production, it's modifying its quality to adjust. That's where the true benefits will come out. But initially, we start off with Industry 4.0 within our own facility. We need to understand that we as operational experts need to embrace Industry 4.0 and see how it will encourage and enhance our efforts. So thank you very much.